today we're going to be continuing our electrolysis topic. We're going to be looking into the reactions you need to know for IGCSE electrolysis as well as electroplating. So in our last video, we covered how you are going to be able to identify which product is formed at anode, which is your positive electrode, and which product is formed at cathode, which is your negative electrode. However, 9 out of 10 times, they are going to ask you for the reactions that are occurring at each of the electrodes. So there are two reactions you're going to be working with, and that is oxidation as well as reduction. Oxidation is the loss of electrons, and reduction is the gain of electrons. Now, this is in terms of electrons. Oxidation and reduction are also covered in the sense of the loss and gain of the element oxygen. However, that is not your concern in electrolysis, because in electrolysis you're only working with electrons, and I might cover that part in a future video someday. But for now, your definition for oxidation, and the one that you're mainly going to be working with anyways throughout your syllabus, is oxidation is the loss of electrons and reduction is the gain of electrons. Now, if for any reason you find yourself not being able to remember this, you can remember this acronym. Oxidation. So oil rig is the word, is loss, and reduction is gain. So to remember what happens at each type of reaction, you can remember this acronym, oil rig. Oh, that is just no. Oil rig. To remember that oxidation is the loss and reduction is the gain. Now, which one happens at which? So at anode, oxidation occurs, always. So at anode, you're going to be experiencing the loss of electrons. And at cathode, we have the gain of electrons. Right. I'm going to be using examples for you to be able to understand how you're going to form your reaction. Let's work with NaCl, aqueous, concentrated. So we know that the product that is forming at cathode is hydrogen. And we know that the product that is forming at anode is chlorine. If you guys want a quick review, since it's concentrated, you're going to have your chlorine go forward and it's going to go to anode because that's the positive electrode and opposites attract. Here you look at the less reactive one, which is hydrogen, goes to cathode. Negative electrode, again, opposites attract. Now, at cathode, you have reduction occurring, so you know that it's going to be the gain of electrons. So you have the hydrogen ion within your solution, so you can write that. Now, here I'm drawing an arrow, and what I want you to remember that when you write the plus sign on the left side of the arrow, that is the gain of electrons. But when you write the plus sign at the right side of the electrode, that at the right side of the arrow, that is the loss of electrons. Now here, you know that it's undergoing reduction, which means that it's gaining electrons. All right, you need the gain, which means you're going to write the plus sign on the left side. And it's gaining an electron. your product that forms is hydrogen, which is H2. Now, hydrogen exists as H2, so you can't have H plus E minus to give H2. You're going to have 2H plus 2E minus, which gives H2. All right, now at anode, we have oxidation. Let me just write over here so you guys don't forget: reduction, oxidation. At anode, we have oxidation. Now we know that at the right side, when you have the plus sign, it is losing electrons. What is losing electrons? Obviously, the chlorine ion that is existing in the solution. It is going to lose its electron, and the product that you have, obviously, is going to be on the other side, is chlorine gas. Again, it's 2, so it's going to be 2Cl minus plus 2E minus. I'm going to repeat this one more time really quickly. When you have the plus sign on the left side, this represents the gain of electrons. So you have to break it down. You know that hydrogen is undergoing reduction. All right, you make the arrow, and you know that your plus sign needs to be on the left side. Now, what is gaining electron? Obviously, your ion is gaining the electron because it's in the solution. And it's gaining the electron, and obviously what's going to form, the product, is going to be on the opposite side of the reactants. H2, you see the 2. Okay, that means that you need 2 of these. Once again, you look at chlorine, you know that it's going to undergo oxidation, which means the loss of electrons, so you're going to make your plus sign on the right side of the arrow. What is losing electrons? Again, your ion is going to lose electrons because that is what you have in the solution, that is what you're working with. It's going to lose your electron, and what is forming? Chlorine gas is forming. Again, you see the 2, you add 2 over there. There we go. So that is how you are going to work with your oxidation and reduction. I hope you guys understood it. We are now going to be covering electroplating, which is possibly the easiest topic in electrolysis. There are just a few points that you need to remember. First of all, I'm just going to explain the concept of electroplating, which you can tell by the name pretty much if you focus on the plating, is that you are given an object and you plate it with a specific metal. So this object is going to be covered in this metal, and that is the entire purpose of electroplating. Now, in your exam, they may ask you what are the reasons for electroplating. The main reason is resistance to corrosion. Obviously, when you add an extra layer, you're adding a layer of copper over here. That is a layer of protection. So you will be protecting your object against corrosion, and so that is one of the reasons that electroplating is done in the industries. It's so your object can become resistant to corrosion. And the second thing is attraction. You can use a shiny, pretty metal. You know, your object could be a spoon and you want it to be silverware, and you want it to be shiny, you want it to be pretty, so you can use the silver metal. So that is another reason that electroplating occurs. Now, the working of electroplating, you need to remember 2 simple points. First of all, the metal that you're going to be using to electroplate is always at the anode. Always. And second of all, the electrolyte has to be a salt of the metal. So your object is always going to be a cathode, your metal is always going to be an anode, And this electrolyte of yours has to be a salt of that metal. So copper nitrate. This could be silver. Then your electrolyte would transform to silver nitrate, or you're going to have to use silver nitrate, obviously. So those are the only two main points you need to remember for electroplating, is that your metal is always at the anode and your electrolyte is always the salt of the metal that you are using. And these are the reasons that one might opt to do electroplating. And that's pretty much it. So I hope you guys understand the concepts that we covered today. And if you found them helpful, and if you know someone who needs the help, copy the link, share it, tell your friends. And yeah, I'll see you guys next time.